Hi, everyone. I'll give it a second so people can kind of get in here. So I guess a quick question for the audience. How popular is Taylor Swift in Switzerland? Like, really popular or like so-so? So-so? OK. Are people aware of her commitment issues? OK, all right. Second question is, how many people celebrate Valentine's Day? Yeah? OK. All right. Like a few, or we like sort of know what it is. OK. All right. Great. I'm just trying to see how flat some of my jokes or puns are going to fall. So today we're going to talk about serverless architecture, but in the context of a love story. And I certainly have a love affair with serverless architecture. I've been speaking about it for about a year. But the technologies are changing so quickly that presentations I gave a year ago are much different now. I'm going to go ahead and get started. So this is me. I'm Lina Liu on GitHub and Twitter, which is probably most relevant here, and various other places on the internet. If you really, really love pictures of cats, you can follow me on Instagram. I'm not on Snapchat. I don't know how to use it. I think that's how I officially figured out that I was old, that I didn't know how to use the filters. I'm from Norfolk, Virginia, in the States, which is like relatively close to Washington, D.C., but southeast, a little bit closer to the beach. And about 12-hour plane flight here with a couple connections. But I organize a couple user groups in Norfolk, Virginia, and a conference called Revolution Conf, mainly focused on JavaScript and robotics. And I work for CloudReach. I work out of the Norfolk, Virginia office, but we do have an office here in Zurich that I have not been to, but I'm hoping to maybe to check out tomorrow. But we're a cloud enablement and innovation company. I'm a cloud enablement leader there. I have a team of about 25 people that are all software engineers and data engineers. But now we're back to serverless architecture and why we're going to fall in love with it, if you haven't already. But before you can fall in love with serverless architecture, you have to get rid of your servers, break up with them. Endorsed, of course, by T-Swift. And just to sort of frame the story that we're going to go into today, we're going to talk about how serverless architecture has breakups and decoupling. The breakups, of course, are with your servers, your physical servers. And commitment, or maybe like also not commitment. Highly cohesive relationships. High availability, if you're into that in your relationships. Dedication. And then, of course, support and growth. We're talking about scalability. But first, we have to talk about what is serverless architecture. And if you've seen any other talks about serverless, they always have a what is serverless slide because no one exactly really knows what it is because it's actually a made-up marketing term. Just like 10 years ago, we started hearing about cloud, and we had no idea what it was, but really it was just a catchy marketing term to mean like you have servers somewhere else that you're using. They're hosted servers. And so serverless is our cool, catchy term. But serverless architecture isn't about any particular compute product. If you read a blog and they say, serverless architecture is AWS Lambda, serverless architecture is functions as a service, they are full of lies, and you should go to a different blog, because that is actually not what it's about. I'm going to talk about that a little bit more later. But like the really interesting thing about serverless architecture and what makes it really powerful are the events. And really, before we were calling it serverless, we were calling it event-driven architecture. And that's kind of what allows it to be so decoupled. And so this is the definition I'm going with for right now. And this has evolved over time. And there's a little bit of holes in this, because you might say, well, what about Firebase? What about Athena? What about serverless databases? OK, yeah, there's lots of different architectures that you can call serverless. But I tend to say that functions as a service is a building block. and that typically you're using some sort of functions as a service product, whether it's one that's hosted by one of the major cloud platforms or it's some sort of tool sitting on top of Docker or Kubernetes. But the main part, though, is that you're using managed functions. And so now we'll talk a little bit about FaaS, and we'll kind of get back to to events, which is the thing that I find so important. But also, funny story, I was not sure how popular the Fresh Prince of Bel-Air was in Switzerland, but last night I watched 3 dubbed episodes in German in my hotel room. So now I know that we like the Fresh Prince. And so I'm using the term execution environments here because I used to say that they were running in containers. And the Amazon representatives told me specifically that they are not using containers, that they are called execution environments. So anyway, I changed it on my slides. But some of the cloud providers are absolutely using containers, and they'll tell you straight out, OK, this is Docker or this is Kubernetes. But Amazon, they're special. They have their own special environment that I would probably call a container, but that they would like me to not call a container. And these execution environments also have runtimes. And depending on the provider, you choose the runtime. You say, I want Node.js 6, or I want Java, or I want Python. So like I said before, functions as a service are the building blocks of serverless architecture. They are not managed by you. Hopefully, they are managed by some sort of cloud provider. And as a software engineer and not an ops person, I really like that because, there's nothing more frustrating than trying to set up a project, especially when it's a proof of concept or, you're just like trying something out, and then you have to spend 2 days setting up a bunch of infrastructure. Like, OK, now today I'm going to learn Kubernetes so that I can create a bot that tweets something. Or, I need to show this client, how to set up this architecture real quick. And then you have to go through so much ops headaches to just get your code out somewhere. So that's why I really like these. And also, they're really inexpensive. So if you're doing a POC or a project, or you're just trying to get something off the ground, any functions that you're not using, you don't pay for. You're not paying for, for instance, in the before days, you have a WordPress blog that you're hosting out there. Maybe you have many, many WordPress blogs, and you're just paying for them to sit somewhere. Maybe no one's even hitting your cooking blog or your I Love My Cat blog, and you're still paying for it. If it's serverless, you're not. As long as those functions aren't being executed, you're not paying for them. So your code is completely free until it's not free. But even if you're hitting functions, short running functions like thousands of times, it's still really, really hard to get very expensive. When I was at Serverless Conf, I was watching a talk from A Cloud Guru. If you're not familiar, they're a training site for certifications, and they have some serverless training courses. But their entire platform is serverless, built on AWS Lambda. And so their operating costs per month are just in the hundreds of US dollars, which is pretty impressive for an entire hosting platform that has hundreds of thousands of users. So these are the sort of major cloud platforms I'm going to talk about. I'm going to kind of skip over some of the tools like OpenFaaS and some of the more hybrid things like Knative, and just talk about Lambda, Azure Functions, IBM Cloud Functions, and then Google Cloud Functions. Just as we're kind of working through the building blocks of this system that we're going to fall in love with. So yeah, AWS Lambda, I'm calling the popular kid in school because a lot of times when you're talking to people about serverless architecture, they think you're talking about AWS Lambda because it just was the first. And really, they're just far ahead as far as feature sets and technology. They're really far ahead of the other cloud platforms. And that's why I'll kind of talk about how the other ones are different and how they're sort of tackling problems a little bit differently because they know they can't just chase Amazon's tail forever. They have to identify in a different way. But Amazon really goes after the enterprise customer, and they do that really well because they use Lambda internally. So they have to make sure that their performance is always top notch, and they have to always have an eye on availability and performance, because if they're using it internally and they're an enterprise, then it has to work. It has to work for other enterprises as well. I mean, one of the downsides is that companies that are gigantic retailers don't want to use AWS Lambda because they see them as competitors. Also, I mean, Lambda really doesn't care about the individual developer. They don't care about your offline experience. They don't care about if you want something to be open source. They care about we're supporting the enterprise. So next we'll talk about Azure Functions. And since Azure is Microsoft Azure, it might be a little bit weird for me to say that they're a developer's favorite or any user's favorite. But if you talk to any of their evangelists for Azure Functions, this is what they will say. And this is, in fact, their focus is the user. If we get user buy-in for Azure Functions, then that's how we get in. That's our starting point, which is very different than we exist to support the enterprise. And so they really are working on a lot of tool sets for offline development. If you set up a serverless architecture within Azure, you'll kind of notice that the user interface is really good. The AWS interface, not so good. So you can almost just like drag and drop really to make a serverless architecture. And it's getting to the point where you don't even need to kind of be a coder. I mean, I think that and this is maybe a little bit of a tangent, but I think that our definition of developer is kind of changing, or our definition of engineer is kind of changing, because it used to be an engineer was someone who wrote a lot of code, a software engineer. But now we're still engineers, but perhaps we're learning to use tools. And like these services within the cloud, we're using those like building blocks with minimal code to create these architectures. So it's kind of interesting that they're getting to this place where I just drag my Twilio API or my Salesforce API, and now I can have events firing from those different outside APIs to create this architecture. So IBM Cloud Functions. So IBM Cloud is really widely used. The Cloud Functions, which is backed by OpenWhisk, not so much. And it's not because it's not a great system, but it's just, I believe they have a little bit of a marketing problem. But it's really great. And if you want everything to be open, if you have a company that really just can't use something like AWS Lambda that basically operates like a black box that you can't see into, then Cloud Functions is great. And really, I mean, Azure Functions is becoming more and more open, and they have a lot of their runtimes are published publicly. But IBM Cloud Functions, that's based on OpenWhisk, is completely open. So you can see all the code, you can see all the runtimes, you can create your own runtime using Docker. If you're really into Perl or COBOL and you don't have a runtime, you can create it in Docker and use it on IBM Cloud. And so that's being open is of course great value. And so Google Cloud Functions, while Cloud Functions have actually existed for a while, the tool, it just went GA, or generally available to the public just recently, just of the last Google Next, I believe. So it existed, but it wasn't really considered to be a service, because it's not something you would recommend to a client or that you would back an important system with, really, if it's not, if it's still in beta, essentially. So now it's in GA. It supports Node 6 and 8, and Python, and I think Go is now in beta or alpha. Also, this is kind of interesting too. I mean, Google also has not really been known for being open, much like Amazon and like Microsoft of the past. But Google Cloud Functions is coming out with serverless containers. It's in alpha preview right now. And so that means that you're soon going to be able to define a runtime kind of like OpenWhisk, like, for if you want to run COBOL or Perl on Google Cloud. So yeah, that's going to be really powerful too. And the idea is that you would host, your containers in GitHub, but instead of Docker, this will be Kubernetes based. So those are kind of those 4 clouds are kind of the 4 different tools that you can use, and sort of depending on what you need, and then this becomes sort of your building block. We've got some more fresh prints happening. But sort of back to the events. And so the really interesting thing is that these functions that you're creating need to get triggered somehow. And so instead of like function calling function, like traditionally, now it's event triggering function. And maybe that might still be an HTTP event through an API gateway. But also, if you have something like an S3 bucket in Amazon Web Services, S3 fires events. SNS fires events. SQS is now can trigger lambdas as well. So really, lots of different ways that you can architect a system. Like I said, using these building blocks to create this architecture. And so also, these functions are naturally microservices, or really nano services, because you want to write your functions as a service extremely small, because the smaller they are, the more performant they're going to be. So you don't want these, gigantic functions. You want to break them down as small as you can. So you naturally create this microservices architecture that's very lightweight and fast. And all the definitions of a microservices architecture, all the things that you want by definition, just kind of come naturally as you're building these functions. And each function is independent. It's not dependent on any other services. And because it is an event-driven system, you're not, unless you're like, wanting to use an anti-pattern, you're not going to have a function call a function, have a call a function. You're going to use something like step functions, which is kind of the state machine that's built into Lambda, or you're going to use these other services to execute this entire system. So you can see all these microservices that are circling around in the step functions here. That's a joke. Poor Taylor. So hopefully at this point where you're already starting to get really interested in getting started if you haven't already. And so, yeah, this is why I think this is really a great match for not only, like I said, proofs of concept or apps you're playing around with, but this is great for larger applications, enterprise. We're building data pipelines that are serverless, backing entire web applications with a serverless API layer. Really everything from a really tiny system to a really large system you can architect using the same methodology. And really you get all of the great advantages of a fully hosted system, right? You get the scalability. I'm still going kind of with my relationship theme here, but obviously your system's not going to go down like it would if you were hosting your website in some local provider or under your desk or something. And so it's really kind of ironic that you can host your website on Amazon. It's always going to be available. You're going to get all the benefits of Amazon, but it somehow ends up being really cheap or free. It seems like there should be a catch, but as of right now, there's really not. So now we have to go to kind of the downside of relationships, which is our commitment issues as developers, and we all have them. We don't want to commit to anything. We don't want to call some library our favorite library, and then it becomes uncool, and then we have to move on. And so how do we, if we've already committed ourselves to something, and we decide it's completely uncool, then how do we move to something else without getting fired by our boss or our client or having to spend a bunch of time rewriting an app? And so there's a couple ways that I would suggest that to kind of get over this commitment phobia. And so like one thing to kind of think of, this is a little bit of a cop-out, but each cloud platform does have services that are very similar. And so if you design a system using these building blocks like I mentioned before, like if you're moving from Lambda to Azure, they're both going to have a database like Dynamo versus Cosmo, or like S3 buckets. IBM has their own version of storage, and so really moving from one to another, you're still dealing with the same kinds of services. So that certainly helps. But the other piece that I would highly suggest using serverless architecture is just to use a framework. And serverless framework is certainly one that I really like. And the reason that I started using it, about a year and a half ago or so, is I think even back then they were only on AWS. You could only use it with AWS, but there was that potential, that roadmap of we care about other platforms, and we want to write plugins so that you can use this for the 4 major platforms and like various other services, like you can use it for kubeless, for example. So some really cool things about serverless framework. For me, being a JavaScript developer, I like that it's written in Node. That might not be so great for Python developers, but you can use it with Python. You can use it with C#, Java, Go, various other languages. So really, like if you hate Node, you only really have to use it to install, and then you can kind of like get past that and go wash your hands and then write Python for the rest of the day. But as most frameworks, it abstracts out a lot of the provider-specific tasks. Because really the command line tools and just the tooling in general for all the cloud platforms is awful. I mean, that's my opinion. This is my talk, so I can kind of say what I want. And I think they're all awful. Microsoft is like sort of leading the pack as far as like we're going to create tools that developers are going to like because that's what they care about. AWS SAM is just not there. I find it to be kind of buggy, and it's just so AWS specific. And so if you're a software developer and you don't care about ops, then why would you have to know CloudFormation really well, for example? Or why would you really need to know the like inner workings of each cloud platform beyond just knowing the services? Because that's really it's sort of taking away from like what you're really good at, which is writing code. You just want to write code. So the more of these like ops type tasks that you can abstract out, the better. And it's got a pretty easy CLI. You can pretty much just scaffold out an application pretty easily and deploy pretty easily. And so this is what the code kind of, or the command line kind of looks like, and what the scaffolding looks like to get started. So basically, you install it. If you don't like JavaScript, just kind of close your eyes for a minute. I'll get through it fast. But this is if I'm creating this cat name service here. This is how I scaffold it out. I'm not the plugin I'm specifying right here is AWS Node.js, and then it sets up package.json for me. Serverless YAML is their file that they use for all their configurations. Handler.js is sort of the meat of your hosted function. And so maybe you'll have other libraries that you'll add to this, but that's sort of the basic building block. And then here I have a dog name service too, because I'm kind of showing that I could have cat name service could be AWS, and maybe dog name service is Azure. And I could just have them in the same repo, really, if I wanted to, like a mono repo. And then using Serverless Framework, I just go in and do serverless deploy on each of those, and it'll just deploy it to the cloud platform that I say. So this is what the serverless YAML looks like for this cat name service. Like I said, it's AWS. It's Node 6 here. I could use 8 or whatever the runtimes that are available for this platform right now. Right now, I'm just using 6. And I kind of say like what the handler's name is, because that's going to be in the code. On this one, I have events and HTTP, which is me setting up an API gateway for cats /name. And if anyone's has tried setting up an API gateway, like logging into the AWS console, it is painful, very painful. It's like you have to hit next like 12 times to get to the end. And even then you're kind of like, did I set up cores right? Like, yeah, so this is like much, much easier. And I mean, you have to kind of just suspend disbelief for a minute and say like, okay, I'm putting all of my scaffolding into this, the hands of this framework. But sometimes you just have to commit to the framework and not necessarily the cloud platform. And this is what my node handler looks like. The framework will let you package it up in the command line, or you can deploy it, which will package it up and deploy it. Kind of, if you don't really want it to, if you have a lot of infrastructure that you need to scaffold separately from serverless architecture, under the covers it doesn't use Terraform. I wish it did. I think that might be a future state, but for right now it uses CloudFormation or whatever is proprietary for each platform under the covers, but you can use it with Terraform kind of separately if you want to use, deploy all your infrastructure with Terraform and then use this for just Lambda and API gateway and things related to actual serverless. And here I'm just kind of illustrating how the handlers look different inside of each plugin, but it's still pretty much similar. And I just made up these library names, so don't try to use Google DB module because it doesn't exist. It's from my head. But basically, I'm trying to sort of illustrate here that if you keep this handler.js, if it's yucky JavaScript, you keep it super small, and then you can use some libraries with your code. That way, it becomes even more reusable. Okay, so I've given some other talks, and this is a subject that comes up quite a bit when I've given the talks, because I've talked about event-driven development, but really the elephant in the room is that each cloud platform fires events in a different format. And so AWS knows what an S3 event looks like, and it's pretty easy within their system for an S3 event to trigger Lambda. But each cloud platform does things differently and does some things better than others. So for example, maybe if I think Google has the best machine learning APIs, and I think that AWS, their services are meh. That's my opinion. Not my opinion, but someone's opinion. Then how do I fire from one to another? How do I do this kind of weird hybrid cloud thing if the events are completely different? And so there's been a lot of talk about standardization here. And so I'm going to get a little bit deeper for a second, and then we'll kind of pull back out. So now we'll talk about cloud events for a minute. And so cloud events is this specification that's kind of still in the works, still kind of very beta. But the idea is that it's a way for all of the events for each cloud platform to be standardized so that it's easier to go from one cloud platform to another. So we're still sort of addressing our commitment phobia here. We don't want to put all of our eggs in one Amazon basket. That's in my opinion, that's a really great basket to put all your eggs in. If Amazon just isn't good enough for you, then okay, I get it, but it's pretty good. It's better than the older days of your cloud provider down the street or something. But as of right now, Azure Event Grid natively supports the current Cloud Events JSON schema, which is really nice. And so you can use whatever their proprietary format has been, or you can choose Cloud Events within their event grid. So they're already saying okay, we're fully on board with the standardization because they're trying to be developer friendly. And like I said, we have some commitment issues. So they understand because they care about us. But the other cloud platforms are a little bit slower. So in the meantime, the makers of Serverless Framework at serverless.com also have Event Gateway, which is essentially a shim. and it uses the kind of current Cloud Events JSON schema like as it exists at the moment, and it's kind of in flux and evolving. But it uses that. So if you can run your events from AWS through this shim, and then ultimately to GCP or wherever. If you watch some of the videos from KubeCon Europe, I think this past year, Kelsey Hightower and Austin Collins both did demos where they showed how you could go across many cloud platforms, including like Alibaba. It's really, really cool. So anyway, this is kind of the future state. And IBM, of course, is involved in this too because everything's open for them. OK, so now it's time for everybody to help me do a demo. Besides like saying a little prayer to the demo gods, if you would, if you are on Twitter, go on Twitter and just write a tweet that mentions these cats tweet, which is a valid Twitter account, and just use the hashtag ValentineBot. And so that's going to kind of fire off my serverless bot. And then I'll just make like a change to it and show you how easy it is to deploy over conference Wi-Fi using Serverless Framework. And it'll it'll totally work, like every time, 60% of the time. So actually, let me go up here to GitHub. Sure. ValentineBot. I realize there's a lot of S's and E's in there. These cats tweet. You can also go to the GitHub account, which that is not nearly big enough. So Linaloo is my GitHub account. Valentine's Day bot is this bot that I wrote that's pretty simple. It uses Serverless Framework to deploy to AWS. I have an AWS folder here because I'm working on just making a GCP version of it with the new kind of GA GCP. And then it looks like a pretty standard kind of node app here. But if you go to this GitHub repo too, I've got instructions there with the hashtag and the Twitter account. Actually, this is the Twitter account here. It just follows other cats and dogs, of course. So I'm going to tweet to myself just in case everybody gets stage fright or something. They don't want to do it. But you just have to mention it. You don't even have to do a reply. All right, cool. It's in a tweet, which says good things about the stability of the Wi-Fi here during my demo. So this is a pretty standard, just bump it up one more, pretty standard scaffolding here, like I showed before. I'm just using Yarn to install just because it's a pretty standard node app here. Reply to tweets is the handler that we're looking at today. Reply is another handler that I've been working on, because this project is kind of always evolving. Just a note, so on my GitHub, I just, anything I'm working on, any fun stuff, I just push to GitHub. And I think people have tried to say maybe you shouldn't do that, but I've never been proven that it's a bad idea. I like it when people have questions, I can just say, oh, go look at this Valentine's Day bot I wrote and I did a thing here, or look at this IoT project. So I tend to put a lot of stuff there, and it's sort of this maybe not totally accurate but fun Stack Overflow. So I've got all kinds of fun sort of serverless stuff there. And this is kind of what the handler looks like for it. It's pretty easy little bot. I mean, it basically just goes out there and looks and sees what kind of mentions I have for that hashtag, and then it sends a little fun response. And this is the serverless YAML. And so this schedule event is just a CloudWatch event, so it's just essentially cron. And I've got 2 minutes on here, but I could put cron in here if I wanted to. Like I said, this is all pretty basic. All right. So now I'm going to get me maybe make this a little bit bigger too. So this is the same project that I just cloned here. I'm just going to close that so we have a little bit more room. And all of so the bot will respond back with like a fun little GIF, and then it'll also send back a message to the person. And so this response list, this is super sophisticated here, just has all like your different possible responses. So we're just going to add another response here, and then I'll show you how you can deploy it. And then maybe you'll get this response. It's just choosing one randomly. So I have to include a pun in here somewhere. I don't know how many people use VS Code, but it seems like I'm just throwing lots of love for Microsoft, but I really love VS Code. I've used lots of editors, and I come from a Java background. And I never, once I started writing code in Node, I never felt like I was ever in love with an editor again. I always felt like editors were much better for Java, and now I feel like I'm happy again. So I just do serverless deploy here. And this is going to accept this new change I made. I didn't actually run my linter, so I just like did a YOLO deploy there. But typically, I would go through my CI/CD process and actually run my unit tests and lint my code, but I didn't. So that's how it goes. So right now, it's just bundling up my code. It's going to store it in S3, and then Serverless Framework will generate the code formation code and also store that in my Amazon account. And I've got all my credentials and stuff already stored here, so I kind of skipped ahead and had those already. OK, all right, so it deployed on conference Wi-Fi, which says something about the bandwidth. OK, and then so now let's go back to Twitter and kind of like see what we got here. 10 new tweets. How many of them are? OK, awesome, awesome. So these are not people I know. So these are all look like maybe people that are out there. You shouldn't actually get the same GIF twice. So, but it looks like everybody's getting different responses. But I deployed kind of like while people were tweeting too. Like I didn't announce any system downtime. So whoever was like tweeting as I was deploying, like who knows? But it's polling, so like it probably should take a little bit longer and then give you again. Cool. So yeah, starting 5 minutes ago, including from me, these are all the responses with the GIFs in them. These right here, I'm not sure why they didn't have GIFs. We'll blame that on the demo gods or conference Wi-Fi or anything but a bug in my code. Yeah, all right, and these are all of the tweets that everyone sent. Sorry, I'm just showing your work in front of the class here. Oh, those are really adorable dogs. Cool. Awesome. All right, we've got lots of audience participation. Thanks, everyone. This is where we are, which is like the most beautiful place on earth. All right, cool. And Cobol followed me and tweeted me last night. So I can't wait to make that Google Cloud function using Cobol. All right, great. Let's see if we have any new mentions. All right, awesome. OK, cool. And you can see more of my GIFs here. So now that I'm not actively deploying, it looks like it's actually working a little bit better. So the lesson learned here is don't deploy while people are trying to use your system. Actually run your unit tests. See, I did everything the wrong way just to teach everyone a lesson. Go back to my presentation. OK, all right. Well, that's all I have. I will be around and at dinner, so feel free to fire any questions at me. I'm happy to talk about serverless and other various opinions that I have all throughout the evening. All right, thanks everyone.